Okay, for these examples, for example number 4, A and B, we are going to talk about that little trick of combining fractions together in order to help us simplify some trigonometric expressions and get some identities out of them. So let's take a look at sine x divided by 1 plus cosine x divided by sine x. The thing we want to think about here is what the least common denominator is, or what the LCD is. And we have an LCD, neither one of these share any factors, so we have an LCD of sine x times 1 plus cosine x. So what we're going to do is we're going to rewrite each one of these over a common denominator. We said is sine x times 1 plus cosine x. And let me erase this to make more space here. We'll come back to that a little bit later. And the trick to doing this is we're going to multiply the old denominator by the missing factor that gives us a new denominator. So what do we need to multiply 1 plus cosine x by to give us sine x times 1 plus cosine x? Well, there's a missing factor of sine x. And whatever we multiply the denominator by, we multiply the numerator by as well. So now our numerator becomes sine squared x for that first term. And for the second term here, we have, we're going from our old denominator, which is sine x, to our new denominator, which is sine x times 1 plus cosine x. And the factor we had introduced there to give us equivalent denominators is 1 plus cosine x. And again, whatever we multiply the old denominator by, we have to multiply the old numerator by to give us our new one. So our new numerator becomes, when we distribute cosine x into 1, that gives us cosine x. We distribute cosine x into cosine x, that gives us cosine squared x. Okay, so let's focus on this and let's talk about what identities we can pull out of this. One of the trigonometric identities that shows up a lot is that first Pythagorean identity that we talked about, which says sine squared of an angle plus cosine squared of an angle equals 1. So anytime you can pluck that out, that will help us to reduce stuff and make it much easier. And if you can see, we do have that over here. We have those factors, we have those terms sine squared and cosine squared. We can rewrite it too if you want. We can call that sine squared x plus cosine squared x plus cosine x all over sine x times 1 plus cosine x. And the reason I did that is just remember that addition is a commutative operation, so we can kind of shuffle it around like that. But now we can see that this value is equivalent to saying 1, because sine squared plus cosine squared is equal to sine squared of an angle plus cosine squared of an angle is equal to 1. So I'm just going to call that 1. Everything else is going to stay the same. And hopefully over here, or hopefully you can notice as well, now once we've combined it and once we started reducing it and simplifying it, now we can take a look and see the numerator and denominator share the same factors. They both have those factors of 1 plus cosine x. So remember, the fundamental theorem of rationals tells us anytime the numerator and denominator share factors, we can cancel them out. So this, I'm sorry, I missed my x over here. So this is the same thing as saying 1 divided by sine x. And we can simplify that. Remember, 1 divided by sine x is equivalent to saying cosecant x. So this whole thing in the beginning, just by finding a common denominator, a bunch of the identities kind of fall right out of it, and it's equivalent to cosecant of x. And there's a little symbol that we use in math when we're done with something, when we're done proving it. We can put a little box on the bottom, or we can write the term QED, which comes from the Latin term. I'll talk about that a little bit later. But this is it. This tells us that the proof is over and we're done. You can put a little square, the little QED. Let's try one more example. Part B says, let's take a look at cosine x divided by 1 plus sine x minus cosine x divided by 1 minus sine x. It's important to note that these are not easy, but you just need to practice them. And when I'm looking at these, I have the trigonometric identities memorized. Keep a picture or keep a list of all the trigonometric identities next to you so you can constantly go back and refer to them and look for them. It'll make your life much easier. Okay, let's take a look at this one. And again, we're using the trick of finding a common denominator to help us to combine them. These don't share any factors, so we have an LCD of just the product of those, which is 1 plus sine x times 1 minus sine x. Okay, so let's use that trick of how do we get from our old denominator to our new denominator, where we're going from 1 plus sine x to 1 plus sine x, 1 minus sine x. So we have to introduce that factor of 1 minus sine x. Same thing over here. I'm going to have to introduce that factor of 1 minus sine x. So our new numerator becomes cosine x times 1, which is cosine x, minus cosine x times sine x. That's for our first fraction. Now let's take a look at our second fraction. I'm going to put a minus there because we have that it's for our second fraction here. And let's see, to get from 1 minus sine x to 1 plus sine x, 1 minus sine x, again, we had to introduce that missing factor of 1 plus sine x. So now we're going to multiply the numerator and the denominator, the old denominator and the old numerator to give us our new one. And let's see, I'm going to put like a little parenthesis over here because I have that minus. Cosine x times 1 is cosine x. And cosine x times sine x is plus cosine x sine x. All right, so let's see what we can do with this. First of all, I'm going to keep my denominator as 1 plus sine x times 1 minus sine x for now. We might have to play with that in a little bit. And distributing that negative into my numerator, we have cosine x minus cosine x sine x. Distributing that negative in, minus cosine x minus cosine x sine x. So let's see what happens. When we go to simplify that numerator, you can see that these guys are going to cancel. Those two factors are going to cancel. And these, we have like terms. Okay, so we can rewrite that as, we have two of them, negative 2 cosine x sine x, divided by 1 plus sine x, times 1 minus sine x. Now, in regards to this, you could, again, like I said before, there's a lot of different answers where you can stop. So you could stop right here. But I can continue going as well, because if I were to multiply out my denominator, it's important for you to know, and because we're getting to the proof section soon, kind of when to stop and when to continue. Again, if this is what you want to show, you can stop here. But if we continue to move forward, I can distribute out the denominator, and 1 plus sine x times 1 minus sine x, that's the same thing as saying 1 minus sine x plus sine x minus sine squared x. These two cancel. That's the same thing as saying 1 minus sine squared x. Now, I wanted you to know about this 1 minus sine squared x because hopefully this looks familiar. This can come from one of the Pythagorean identities. And again, anytime you see ones and sine squareds and cosine squareds, think the Pythagorean identity. Now remember what the Pythagorean identity says. It says sine squared of a value plus cosine squared of a value is equal to 1. Well, what does it say about 1 minus sine squared? Well, take a look at what we can do here. We can subtract sine squared from each side. That tells us that cosine squared x is equal to 1 minus sine squared, which tells us that this is the same thing as saying this. So we can rewrite this again as a step further as calling it negative 2 cosine x sine x divided by cosine squared x. And now notice that the numerator and denominator each share that factor of cosine. So this is the same thing as saying negative 2 sine x, one factor of cosine in the numerator, 2 in the denominator. When we cancel them out, we're going to be left with one factor in the denominator. We can still simplify it further. Remember what sine divided by cosine is. Anytime you see sine divided by cosine, that's the same thing as saying tangent. So again, according to, and we're setting you up for the next section for proofs, if what you wanted to prove is this, then we're done. If what we wanted to prove was this, then we're done. If what we wanted to prove was this, then we're done. There are a ton of different equivalent ways or equivalent expressions. It just depends on really what we want to prove. But this is an introduction, and for the next section, we're going to talk a little bit more about how to determine where we stop when we're looking to prove something. Don't forget,